Hi, 119Xers. I wanted to give a quick little review of what we were supposed to have gotten out of the last couple of worksheets before we jumped into me lecturing some more and giving you guys your first real online assignments. So what were we supposed to have learned from those last worksheets? Well, one, we got a lot of notation, right? We got the probability of A. This is equal to the probability of event A occurring. So we can use this notation. I think occurring has one R. It doesn't matter. I think it's double. I don't know. Double R's? That looks wrong. I don't know. We're just going to leave it at that. That way I don't have anything misspelled. Whatever. We got this complement notation, which is the probability of not A. And then we got this idea, this formula that I'll never give you on a test, but this idea that that's just 1 minus the probability of A. So we used a lot of examples here. If 80% of our students own an iPhone, that means 20% of students do not. If 5% of our faculty don't have any way to do this online teaching thing, that means 95% of our teachers do. So just a sort of almost common sense idea that these two probabilities, if we're talking about A and not A, should sum up to 100%. We also got 3 other pieces of notation or 3 other types of probability. We had our AND probability. This is simply just the number of things in A and B over the total number of things. So this typically, if we're thinking about our contingency table, which is a goal of ours is to get everything in this contingency table, is literally just going to be where do these two things intersect divided by our total number. We also had the probability of A or B and the probability of A given B. Now these two are both more complicated. So I'm going to erase the and. These 3 at the top here are simple. These should be something that you can see in the table or even almost in a tree. So the table has these. There's no reason to do any math to get A complement, or A and B. I mean, the most math you have to do is that 1 minus probability of A to get the complement. The second 2 things that we have here were formulas that we were supposed to sort of discover through the worksheets. And these you will have to use formulas to get, or at least intuition. Now, the worksheets had you do these things through intuition from a table. So that doesn't mean you have to use a formula. So I like to point out that there are ways to get around this where you don't need the formulas. We did these in the worksheets without formulas, so it is possible. But formulas can make these easier. The formula that we discovered in the very first worksheet when we were looking at female and male and whether or not people were happy with their test scores was this idea that I need to take these 2 different probabilities, and that will give me all of the A's, all of the B's, but the problem is that I'm double counting the A and B. So we need to make sure that we subtract off that probability of A and B that we double counted. Remove all of the women who are happy with their test scores because we counted them in the happy and we counted them in the women, right? So we discovered that back on the worksheet on last Monday. Now, on Wednesday, we were supposed to discover a little bit more about this idea of a given probability. And like I said, the given probabilities intuitively make some sense. So again, if we're thinking about this, that what's behind the line is what we know. So this is, let me just write it below, A given B. And sometimes you'll see other keywords instead of given. You'll see of or if. Oh, I never even looked to see, shoot, how big my little recording screen is. I might be missing certain shit. Hold on. All right, sorry, I shrunk my screen so now you can see everything. I wrote table and formula. That was really the only thing I think that was really missing from how big my screen was. So anyways, this A given B, like I said, of or if or other ways to say given. Whatever we know, whatever's behind that line, whatever is the of, the if, or the given, that means we know this is already true. So we did this a lot in that last worksheet. We said, okay, given someone is female, what's the probability they like math better or they like English better? So if this is our whole, then we're looking at what is our total. So this is another formula that's going to be given to you on the test. Both of these formulas are. This is the probability of A and B all over the probability of B. But again, you can do this intuitively. So those two things are really the formulas that we were supposed to figure out from those worksheets. In addition to figuring out these formulas and sort of how to use them without using them per se, we were also supposed to get this idea of independent versus disjoint. So that's the second thing we'd want to make sure that we sort of understand. Let me start with the easier one. Let me start with disjoint. And I'll post this entire document up along with this video, so don't feel like you have to have taken notes or the fact that I babbled when you couldn't see everything, all of that. So disjoint was the first worksheet, this idea of like, well, if we're looking at male or female, that's just going to be all the females, all the males added together because there are no overlap, right? There is no overlap. So disjoint was also called mutually exclusive. So if you've heard that language before, I'm sure Gabby has. All right, so mutually exclusive. These basically means that they have no outcomes in common. So if you were to actually write out the event space, which we don't tend to do, you would not have anything in that overlap that you could sit there and say happened, right? So no outcomes in common, A and B cannot occur together. All right, so those are sort of our ideas of what these things mean. And we could also put in a visual here for disjoint. Disjoint, if you were to try to draw a Venn diagram, your A and B would be 0. If you tried to make a contingency table, it just wouldn't make sense. If events are disjoint, you wouldn't make a contingency table. You would just make a table that had your different events and then had the events, right? And then it had the probabilities of those events. So you'd have 0.5, 0.3, 0.2. Typically with disjoint events, these will sum to 1. But we'll see that a little bit later when we get into the lecture notes, and especially when we get into discrete probability distributions. The last thing I'm going to put on here on disjoint land is this idea that exactly what these two things say, if there are no events in common that can't occur at the same time, then our probability of A and B is just equal to 0. Now, students are usually okay with that. Independent is a little more challenging. So independent means that there's no relationship. If we get towards this like idea that we're going to get at the very end of the semester, there's no relationship between A and B. One doesn't influence the other. If you want to stick in probability land, because in probability land we're a little more strict than that, we're looking at knowing A doesn't change probability of B. So you have my example, if you want to put it in there. The probability of liking pizza, this is just a solid 95%. Everybody loves pizza. And the probability of liking pizza for a female, still 95. For a male, also still 95. That was what that last worksheet with the English for math based on gender was really trying to hammer home. That if they're independent, these three probabilities are always going to be the same. That if I find the real probability, the overall probability of pizza, it should be the same for both of my subgroups. So that's the idea of independence. If you wanted another rule here, we have this idea that we haven't seen yet, but we're going to get. So I'll just go ahead and tell you guys. If this is true, if they're independent, we have this AND formula where we can just multiply the two probabilities together. So I like to ask questions about whether or not things are independent or disjoint. And I also like to ask questions about what probabilities are if things are independent or disjoint. So now you kind of see we have these special AND formulas for both independent and disjoint that you maybe couldn't grab right off of, you could get without having a table. So these are the only time we might have separate AND formulas, but you have to be told independent or disjoint Don't make any assumptions about that. That tends to be students' most common errors, to assume independence when it's not really true.